Well, for those of you that are here now, welcome to this Electroair presentation Zoom meeting. We're going to give it a few more minutes before we dive too far into the presentation to let more people join. But while we're here, Daryl, if you want, please take the opportunity to introduce yourself and we can get some of that stuff out of the way.
Oh, I'm already known worldwide. I don't think there's anything else to say.
What's that? You're no.
I'm already known worldwide. I don't think there's much else to say.
I can talk to you.
No,
the famous, infamous Daryl Poole.
The infamous Daryl Poole, the old prop guy, thought he retired from aviation and fell right back into it. Obviously, Smooth Power LLC, master distributor for Electroair. Our sideline gig is we also distribute Hartzell STC prop kits. And we also deal with the TCW Technologies backup batteries for the guys that are going with dual systems. My partner just joined there, Greg Wester. Stole him from the lucrative crane industry to bring him into aviation, and I think he still hates me for it, but it is what it is. But yeah, hopefully, like I said, Mike, I had a lot of guys ask for the link. Put the link up a couple of times on Beach Talk, so I'm expecting more.
Well, we'll give it a few more minutes.
Of course, it's still pretty early for the West Coast guys. Hard to really pick a time to do this that's palatable for everybody from the East to the West Coast.
Well, at least we're not doing it at 9 o'clock in the morning. It'd be 6 in the morning out there for them.
Like your hat, Greg.
Oh, thank you. Got to represent. Need one more tonight. The girls will win that national championship.
We're playing again tonight?
Yeah, they start at 7, ESPN.
That's the girls. They're playing
softball.
Texas.
Yeah.
Girls
softball. In state, they're playing Texas Tech.
Yeah, I watched a little bit of that game last night. Pretty good. Well, I'll take a minute here while we're waiting for everybody to get on board. My name is Mike Kobelik. I'm president and one of the partners in Electroair. Additionally, which is really important to this group, I also own a company called South Seas Ventures. Makes replacement Beechcraft parts, amongst other things, rod end bearings, springs, the little inspection hole clips. I make the really funny looking step. I get it. It doesn't look like a beach step, but it's all stainless steel. It's a pretty stout little step. I am celebrating my 40th. I'm not as old as Daryl, quite, but I am celebrating my 40th year in general aviation professionally this year. I started off with working for my parents at a fastener business way back when up here in Michigan, and then bought another little distribution company. I've bought and sold several different businesses and engineering things throughout general aviation. And in 2005, my partner Pete and I acquired Electroair. It was an electronic ignition business strictly in the experimental world. It's one of the first two that were available in experimental aviation. A guy by the name of Jeff Rose started it. And the whole premise of buying Electroair and taking it over was we felt that it had gone a long way to do all the engineering stuff to be able to get an STC. And it's the old adage, you know how you make a small fortune in aviation? Mm-hmm. Start with a big one. You get an STC with lots of time, lots of money. We earned our first STC in 2011 with 4-cylinder Lycomings. We earned another STC in 2013 with some of our first 6-cylinder systems. And then we've expanded upon that ever since. We're probably approved right now on a little over 500 aircraft models. We've recently submitted our stuff over to EASA for 6-cylinder certification, for dual ignition certification, all of that. We've had an EASA STC for the 4-cylinder stuff for quite a while now. We also have STCs in Brazil, Japan. Apparently we're going to have to do them for Canada. A couple of years ago, they decided they didn't really want to agree to the bilateral agreement, which I thought was kind of interesting. Well, Daryl, what do you think? Shall I start the slideshow?
Why don't we give it about 4 more minutes?
4 more minutes. Okay, well,
Can you talk about yourself for 4 more minutes?
that's a loaded question.
I know you can.
I guess, while we're here, just because I do have a business that's another business related to Beechcraft, does anybody have any South Seas questions that they are burning to ask? What the heck is that about? Why did it get named South Seas Ventures? Anything like that?
Sure. Go ahead, tell us.
So my partner in Electroair, Pete, is the one who actually started South Seas. He had a B-55 Baron a number of years ago, and he got a little fed up with the quality of beach parts, and he started off with, frankly, the little door striker plate on the main door is plastic, and he was a little frustrated with that, so he came up with an aluminum striker plate. That was his very first part. He then also had to replace a step, which he didn't like the quality of the steps that were coming out of beach. But anyway, he was hell-bent for election to do it right, and he ended up getting PMAs and STCs for all this stuff. The name of the company, he used to have a place in Port St. Joe, Florida, in the Panhandle. And at the end of his street is a club called the South Seas Club. And Pete himself is a retired forensic accountant, did a lot of audits. In fact, did some audits for Textron, Bell Aircraft, Bell Helicopter, and others. And so he needed to name the business, and he looked at the sign and said South Seas Club. He says, well, there you go. We'll call it South Seas Ventures. So it's a little unique in the fact that if I make a cold call on somebody like a shop or whatever, they think I'm trying to sell them condominiums in Florida. Not quite. I am trying to sell aircraft parts. And people do recognize that. Once they know it, I think they recognize it. It's reminiscent of a company that we do business with for Woodruff keys. There's a manufacturer out of Pennsylvania for Woodruff keys called Standard Horse Nail. And in fact, they make pretty much all the MS Woodruff keys in the country at this point. And I remember asking the guy, why are you called Standard Horse Nail? It's one of these businesses that's been around forever. They haven't made horse nails in probably close to 100 years now, actually. But they kept the name because they did a lot of work with the big three, the auto industry. And when you're selling into the auto industry, you essentially they corral the salespeople onto a big room, and a buyer will decide whether or not he wants to buy from you. And they got more visits in front of buyers because of the name of the company, because the buyer looks at that and they say, Standard Horse Nail, what in the heck are they doing here? I got to talk to that guy. So they got a lot of shots in the auto industry. South Seas collectively right now, we have a little over 50 PMAs. I've got about 20 of them, 20 more submitted into the FAA, chugging through their process. Hopefully they've started to hire some more engineers, and hopefully they start paying some more attention to our project. Electroair is waiting on them for a lot of stuff as well at this point too. So. And somebody inevitably asks, why do you pick the certain products you make in South Seas? Got to be honest, I pick the simple ones, and I pick the ones that I think I can get approved. And in some cases, I pick the ones that I want to prove a point with the FAA. I've got 2 gaskets, as a matter of fact, Viton gaskets for the beach fuel selectors that they've been sitting there for about 3 years now with the FAA. And at this point, I'm just hell-bent for election to get them approved. I'm going to, by sheer force of will, I'll get it approved, I guess. Well, Daryl, it's 7:10. I think we should get started on talking about Electroair stuff.
Let's go.
And with that, we are going to get started. So we call this presentation Performance Through Technology. We feel very strongly that our system is not just an electronic ignition system, but it's a performance-based electronic ignition system. And one of the things, basic ignition principles, is the goal of any ignition system is to start the combustion event at such time that peak pressure occurs somewhere between, well, about 16 degrees after top dead center. If you talk to the guys at GAMI, they want to see it right at 16.5 degrees after top dead center. Magnetos, because they're fixed timing devices, they're low energy devices, struggle making that, hitting that mark optimally every single time. When we're down at sea level, at high manifold pressures, the fuel air molecules are packed real close together, and magneto can light that fuel air mixture off very well. But as we go up in altitude, the manifold pressure changes, which actually are changes to the amount of air volume or the space, if you will, between the air molecules inside of the combustion chamber. So we're down real low at high manifold pressures, everything's packed very close together. That fuel air mixture combusts at a certain rate. As we go up in altitude, as the manifold pressure changes, those fuel air molecules get further and further apart. What ends up happening is the time for that fuel air mixture to combust changes. It gets longer. It takes longer for that fuel air mixture to combust to develop peak pressure. One way that we can overcome that, and any good propulsion engineer will tell you, is if you cram more air inside of that combustion chamber, you'll do a better job of developing force or propulsion. Well, the electronic ignition system, our electronic ignition system can't do that. We can't put more air in there, but what we can do is compensate for time. A high-performance ignition system needs two things, two critical factors to be able to achieve the goal of that sweet spot of 16 degrees after top dead center for peak internal pressure. You need to have energy, high energy. In the case of the Electroair system, we put out about 70,000 volts through 20 degrees of crank rotation. That's what allows us to open up the spark plug gap on our plugs. We also are able to vary time. We're able to vary the ignition event based around manifold pressure. We'll talk a little bit more about that, but as we get into lower manifold pressures, we advance the timing or increase the time available to get that combustion event going. The Electroair system accomplishes both. Again, very high energy coils, about 70,000 volts through 20 degrees of crank rotation. If we want to go back to physics and really understand it that way, it's about 9 joules of energy. Comparatively, a magneto puts out about, on its best day, when it's very optimal, 12,000 volts through about 5 degrees of crank rotation. And if we're looking at it on a joule basis, it's about 27 millijoules of energy. So very small, short duration spark. And obviously, magneto doesn't have any ability to change timing based on what's going on inside of the combustion chamber. So when you're doing this, most of the time, this is what you can see. Typical fuel savings that we've seen on 6-cylinder Continentals, 6-cylinder Lycomings as well, anywhere between 1.5 gallons to 2 gallons per hour for a normally aspirated engine. Turbocharged engines, the fuel savings are going to be different. They may not be there at all, as a matter of fact, because the combustion chamber is boosted with higher pressure air. So we're not varying the time. We don't vary the timing as much on a turbocharged engine. We do see lots of reports, though, of better EGTs on turbocharged engines, which EGTs translates into lower turbine inlet temperatures. In the Bonanza bearing community, we have seen airspeed increases fairly consistently. If you don't want to see the fuel savings, if you just want to go faster, typically on a Bonanza, we've seen it 5 to 7 knots faster. You can argue and debate that all, and kind of slice and dice those numbers as much as you want. I've got one operator that flies a Piper Lance, that ended up picking up 10 knots after putting a dual system. He removed he had a Bendix dual magneto on the airplane and put 2 Electroair systems on it. And he picked up 10 knots. And he was pretty blunt. Isaiah is a pretty heavy duty data guy. And he said, simply put, the most expensive thing on the airplane is the engine. And the more you can do to save time on that engine, the better off you're going to be economically. So if you go, in his case, 10 knots faster, he was going around the world 1 additional time on that engine. That's a lot of extra flying that you can do. A little bit closer to home, there's a Bonanza operator. I'm in Michigan, just outside of Detroit. A Bonanza operator out of Lansing that was choosing between an Electroair system or tip tanks on the airplane. His mission was to fly from Lansing, Michigan to the Dallas-Fort Worth area, and he wanted to do it without a fuel stop and still maintain his IFR reserves. When he put he could do it VFR, but IFR without any enhancements to the airplane, it was really difficult to do. After he put the Electroair system on, he made his IFR reserves. And that was an achievement. I did get a question, how did he replace a dual mag with 2 Electroair systems, new accessory case? We'll come to it in a minute, but no, he didn't do a new accessory case. He did a mag timing housing, and he did a crank position wheel, and it separated both ignition systems. The other thing that I quote quite often, particularly it shows, is better ramp appeal. We all get to look 20 years younger when we've got an Electroair system on the airplane.
Hey, Mike.
Allow me a little levity.
Hey, Mike.
Yes, sir.
I want to go back and quickly talk about something that we don't talk about enough, so it becomes a little bit more understandable or blatantly obvious. You talked about spark duration of the Electroair system being basically 4 times longer than the spark duration of a magneto, and quite frankly, the spark duration of our competing product. Spark duration is really, really important when you think about what's going on inside that cylinder. Keep in mind that as air and fuel are sucked into that cylinder, it creates a tornadic action. In other words, that fuel and air is spinning like a tornado. So when that spark plug starts sparking and igniting fuel, the longer that event is taking place, and remember, Electroair is high voltage, great big spark plug gap, so a very powerful spark. The longer that duration of that spark is occurring, the more the fuel and air mixture is actually being ignited. When that happens, it propagates much faster throughout the rest of the cylinder, which is where we get the complete burn of the fuel air mixture in the combustion chamber. And again, back to the timing, that 16.5 degrees past top dead center being critical, as that's where you have the most mechanical advantage over the crankshaft. But more importantly, we're exhausting that fuel and using it up. And in the several end results, but one of the big ones that we also don't talk about enough is radically reduced exhaust gas temperatures. And for you guys that already have single systems installed, when you do your ignition checks, take a look at that fancy engine monitor. And when you turn off that Electroair system, watch those EGTs jump immediately, and not just a little bit. That really tells you, that tells the whole story of what the Electroair system is doing as far as getting that fuel completely consumed and in the cylinder where it's supposed to be consumed, and not a bunch of it being consumed or the burn being finished in the exhaust, which is very damaging to exhaust valves, which is the #1 reason that cylinders fail inspection, is the exhaust valve side. So the cooler we can keep the temps on that side of the equation, the longer lasting your engine is going to be. I don't know if you have anything you want to add to that, Mike, but I wanted to make sure that everybody understood the purpose of that long duration spark.
No, I think you covered it really well. If somebody has questions, they can pipe in, or they can, since we're on Zoom, you can send me a chat and I'll try to address it as we go. We talk often about the benefits of this ignition system being fuel savings or being airspeed. Obviously, those are the real sexy things, but there is a significant benefit in reduced EGTs. And as Daryl pointed out, the benefit is instead of burning plasma across the valve seats, which erode those valve seats, what's coming through the exhaust valve are spent gases. And accordingly, exhaust valve life should go longer. We don't have specific numbers of how exhaust valve life, how much longer exhaust valves will last or anything like that. It's impossible to gauge that. But the fact of the matter is, if you're operating with lower EGTs, those exhaust valves are going to last longer. The Electroair system is, as we said, it's an electronic ignition replacement. We are approved for either replacing a single magneto or a dual or both magnetos on the engines. We are also approved to replace the Bendix, in the infamous Bendix single drive dual magneto. STC'd for pretty much every 4-cylinder and 6-cylinder Lycoming Continental engine application you can think of. The typical gains, and again, like we mentioned, the sexy benefits of this are the potential for fuel savings or the potential for airspeed. On turbocharged applications, again, we don't see as much fuel savings, but what we have had back in reports is the ability to lean a little bit deeper at the higher manifold pressures. And that's important in the climb. I had a question in the chat. Again, we are approved for the Bendix single drive dual magneto. Obviously, for the beach guys, that doesn't apply.
It does for a couple of some modified Bonanzas that have the Navajo.
Oh, that's true. Yeah, there's Daryl's right. There are a couple of modified Bonanzas that use the 540 J2BD engine, the Navajo engine, and we are approved on those. The question that came up earlier is, did he have to modify the accessory case? And the short answer is no. The way we did it was to use a mag timing housing. We'll talk about that in a moment, what that is, but a unit that's driven off of the mag drive itself. And then we also have a crank position trigger wheel up on the front of the engine underneath the flywheel. That achieved the goal of getting 2 separate trigger sources to be able to drive 2 separate ignition systems and have them completely independent of one another. I just read an accident report a couple of days ago on a 182 RG that the magneto had been replaced and the technician didn't put the attaching hardware on correctly, didn't torque everything down correctly. And what ended up happening, is the hardware backed off and the magneto literally dropped out of or was no longer coupled to the engine. So he lost both ignition systems. He lost it at about 300 feet on departure, no way to turn back around to the airport, and ended up in a stand of trees. The pilot died and the passenger got beat up pretty good, but he ended up living. I just got a question with the Electroair system and the EGTs going down. What is the effect on the CHTs? Great question. The effect on the CHTs typically is that they do go up. It's not uncommon to see the CHTs go up somewhere about 20 to 30 degrees.
Yep.
Much beyond that, then we start to enter into where we should start doing some troubleshooting. We're a little concerned if they go up 30 degrees that we've entered into, that something's not installed correctly. CHT increases of 50 degrees would be a warning sign for us to relook at the installation of the trigger mechanisms, make sure they were installed correctly right at 0 degrees TDC. Baffling is an issue with CHTs as well. We sponsored a young man in a 182 with, I think, didn't he have the P-Pont conversion, Daryl? Ethan?
I think so.
That he went around the world, and when he started his flight, he had a CHT problem initially. And what ended up happening, what he determined was his baffling had a bunch of little kind of pockets built into it. The baffling wasn't sealing nice and tight up to the top of the cowling. It was kind of wavy. Once he did that and got the cooling straightened around, that solved his CHT problem. They came back down to normal. And most of the Continental engines, and Continental will tell you this as well, the sweet spot for CHTs is right around 375 degrees, 360 to 380. There's a lot of debate about that, I suppose, but Continental has always used 375 as the sweet spot.
When Bob Menace tells you that's the sweet spot, you can take it to the bank.
Yeah, you can take it to the bank. For those of you who don't know the name Bob Menace, first of all, he's a personal friend of Daryl's and mine. He used to be the VP in charge of engineering for Continental. Amongst other things in his accomplishments, he is the person that designed the top induction system for the big bore Continentals. That's all his art, if you will. And we have become pretty good friends with Bob over the years, and he gives us lots of advice and recommendations and observations about Continental engines. He is one of those guys that has probably forgot more about engines than most people will ever know about engines in their lifetime. This next slide here has to do with the installation, and one of the things we do a lot of training with installation centers across the country. The shops want to become an installation center. We run them through a 3-hour class on a Zoom meeting, and we take them through a lot of the particulars of the system, the components, and then we start talking about installation. In this case, one of the things that we always tell everybody before that installation begins, make a plan. The kit, as I'm sure most of you have been to our website and you've seen pictures, and you can see the picture up here, is not a single unit that goes into the mag hole. There's just no way to get the coil energy that we need out of a coil small enough that will go in a mag drive. So we've got components. These components get mounted in different spots. When you're getting ready to do an installation, you want to make an installation plan, and ideally work with your technician to make sure that that installation plan, both of you agree that it's accomplishable or can be accomplished. You agree with the scope of the work and you move forward. We also get questions quite often from owners of how long does it take to install? For a 6-cylinder engine, I would tell you to budget for 3 days, 2 days for sure, and the third day to catch the things that you didn't know you were going to run into. There inevitably is always going to be something. We've one of our installation centers has developed a couple of pre-installation checklists that go through things you should look on the airplane in terms of systems and setups. I know everybody is flying a perfect airplane and there's absolutely nothing wrong with them. But the truth of the matter is, in my experience at any rate, and this is over several thousand airplanes now, there's inevitably something that's not exactly perfect. And not that the airplane has to be perfect to have this system, but these are things that you want to be aware of. So there's a pretty extensive checklist of things that you should look at as a pre-installation checklist. Make sure your technician is aware of it. And then there's also a suggested procedure for how the components go on. This is something that, again, one of our installation centers developed. It's what's on the website tonight. Please don't go there because it's missing some information. I got to get it updated, and we'll do that in the next day or two. But it'll be available online, or if you want, email either Daryl or myself, and we'll get you the list. It's a handy way of, as you're going through the airplane, making sure that a lot of these things are kind of up to date and in good shape. Now we'll launch into the individual components of the system. The very first part of where this ignition starts is with a very highly accurate trigger mechanism. I've got 3 of them pictured here. The unit on the left is our 4-cylinder Lycoming mag timing housing. The unit in the center there is the most common one that we sell. It's our 6-cylinder mag timing housing for the Continentals. That would be typical of what goes on most of your airplanes. The picture on the right is our crank position sensor, also for the Continentals. Everything about this has to do with getting our trigger wheel spinning 1-to-1 with the crankshaft. That trigger wheel passes by a magnetic sensor, creates a pulse, and gives us the engine position and RPM information fed into the controller. We have a variety of ways of attaching a crank trigger wheel to the engine. Most common are with the mag timing housings, because that's a drop-in replacement for the magneto itself.
Auto lock changed.
I'm sorry? Okay, I thought I heard a question. This is an installation on an IO 550. You can see the mag timing housing in the left-hand position, the right mag left, and the magneto in the right. On the Continentals, both magnetos are impulse coupled magnetos, so it doesn't really matter which mag you replace. The left position on the Continentals, because of the forward facing part of the mag drive and also because of the case, allows you to rotate the mag timing housing and get some clearance around the sensor wire coming out. Here's another picture. This would be in the right hand side, obviously on the Continental. There is plenty of clearance there. They've got the unit rotated so that the sensor wire is not going to have any issue getting turned or bent, not going to rub against the top of the engine, anything like that.
Hey, Mike,
Yes, sir.
make a quick comment on the crankshaft trigger wheel. I'll be quite frank, not a big fan of using the crankshaft trigger wheel on the Continentals. Main reason is it's just very exposed. We actually had a Bonanza operator over in Arizona that opted to go with the crankshaft trigger wheel, which I get it. It's a little bit cheaper kit, but he picked up some FOD on a takeoff roll that got in between the magnetic pickup and the trigger wheel and actually snapped the bracket, which effectively killed the ignition. When we use them on Lycomings, especially the guys that are having to replace the Bitic single drive dual mags, that great big starter ring gear does a really good job of protecting the crankshaft trigger wheel from any potential FOD. So just not a real big fan of it on Continentals for that reason. But also another big thing, most everybody now has gone with a Hartzell propeller on their Bonanza. Hartzell uses an obnoxiously long mounting stud on their props, and that extended stud, which is totally unnecessary, takes up the space that we actually need to install that crankshaft trigger wheel. A few years ago, talking to my friends at Hartzell, I got them to agree that you could actually send your prop into a shop, put in a shorter stud that they actually use on the Continental 360 series 6-cylinder engines. It's still plenty long enough to have sufficient locking from the self-locking nuts. Talked to them here a few months ago about, and they never got it in writing. Talked to them about it a few months ago, and they acted like they didn't know what I was talking about. So short of taking a hacksaw and cutting those studs off, if you've got the Hartzell prop, the mag timing housing is the only way you can get it.
The other thing I'm going to add in there, Daryl, because there is, like everything, there's always exceptions to the rule. We ran into an install on a B55 Baron that had alcohol feature props on them, and the way the cowling was contoured to the engine, there was very little space between the top of the mag timing housing and the inside of that cowling, and they were concerned. The shop was concerned, and I got to be honest, after I saw it, I was concerned too about there being wear on the inside of the cowling. But as I'm looking at where they had the mag timing housing at, I'm standing in front of the engine right at the prop, and I look down, and there's all kinds of space on that crankshaft behind the prop. Now, this particular Baron had alcohol feed shoes on it, so they had to reroute one of the alcohol lines to get clearance, but the crank trigger wheel was really the only option they could go with, and that worked out really well. That particular Baron, the goal of the owner was to go from Denver up to Seattle. He's a dentist, to go to Denver to Seattle nonstop with a bunch of his equipment. The airplane itself is now out in Iowa, I think. Still flying, and flies like a homesick angel.
Well, there's always an exception to every rule, right?
There is always an exception to every rule. That's right. The nice part about the system is that because we have the flexibility of being able to do that, we should be able to get this system on just about any engine that we might encounter. And in fact, here recently, we just finished an install on an older Bonanza on an E185, 205 horsepower E-Series engine. That, for those of you who may follow a guy by the name of Ben Weeks, he does a lot of YouTube videos about older Bonanzas and that sort of thing. He should be putting up some videos, I would suspect, in the next couple of weeks or a month or so, about the different things that he's seeing with having put the system on his airplane. Moving on to the next part of the system, the controller, what we call the controller, is really where the magic is. So the crank position sensor, the MTH, gives us the signal, it generates a signal that gives us the engine position and RPM information. This unit, the controller, also, you'll notice in the picture, has a little nipple on it for the manifold pressure line. That's where we bring in there's a pressure transducer on the board, and we bring in manifold pressure there. That creates a voltage now that we can do something with and adjust timing based around manifold pressure. We do not advance the spark timing with the engine above 24 inches of manifold pressure. And typically we do the spark advance is 2 degrees of advance for every inch below 24 inches. Now, having said that, I said typically, so there's a couple of different alternatives here that we can do. With turbocharged engines, it may make sense, depending on the operator and some of the conditions, to just remove the manifold pressure curve entirely. The engine is always above 24 inches typically, and won't have any impact on the variable timing. The benefit for the turbocharged applications is that really high energy, long duration spark, especially at altitude. We'll talk about the coils in a minute, but suffice it to say, the energy from the coils are not passing through a distributor and are not running the risk of jumping around or arcing inside of that distributor. They're firing directly from the coil into the spark plug. The other curve that we've got is for our top induction Continentals. We call it the top flow curve, where we shallowed the curve, so to speak. Instead of advancing at 2 degrees of advance for every inch below 24 inches, we advance at about 2/3 of a degree for every inch below 24 inches of manifold pressure. That shallowing curve is compensating for the fact that the top flow induction engines have a tuned induction system. That induction system is really, really efficient and does not need a lot of additional advance or timing advance added into it. How we came up with the top flow curve, and actually how we came up with both advanced curves, frankly, is through flight testing. You go fly an airplane, you set it up for different flight parameters, you adjust the timing. We have an outside device that can vary the timing while we're flying, record the peak RPM, which is your most amount of torque, plot that out. Turns out it's a straight line. Both cases, it was a nice straight line on the graph. One other comment about the controller, and about really any electronics, is we want the controller mounted on the cool side of the firewall, anywhere in accordance to Part 4313. You'll see as you go through the installation manual, sprinkled throughout there is install this in accordance to Part 4313. And the reason for that is we don't know, again, we have over 500 aircraft approved on our AML, and all of these airplanes have got some amount of variability to them. I mean, a G36 made in 2004 is way different than a 1979 A36 TC. I mean, they're the same type certificate, but who knows what's been done, and there's no way for us to know that. So the FAA gave us the flexibility in the installation manual to allow the installers to install these components based on the airplane that they were seeing. So we don't become too fixated on the controller, we want it in a cool environment. If it's underneath the instrument panel, that's fine. If it's all the way in the back of the airplane, that's fine too. There's no degradation of electronic signals just because the wire harness is long, not significant enough where anything would be noticed. So again, the flexibility of the system allows it to be installed on the airplanes that you're facing, and you're not stuck with some preconceived notion that an engineer in our office thinks is the right thing. The next component, and we've talked about this already, are our high energy coils. These high energy coils, like we said, put out about 70,000 volts through 20 degrees of crank rotation. They fire directly into the spark plugs on the engine. They do not go through a distributor, so you're not losing any voltage or energy by passing it through a distributor-like device. The other benefit of it, as you go up in altitude, the wires are on it, there's no chance for arcing internally inside of that distributor. The whole reason that a 1200 series Bendix magneto, and interestingly enough, this is another Bob Minnis story, the whole reason that a 1200 series Bendix magneto came about is when Continental was flight testing turbocharged 360s, I think it was, on Senecas. They got to altitude using a conventional Bendix S200 series magneto with a small distributor, and the engines just start running rougher than a cob. Turned out the magnetos were arcing internally because the air density had gotten down to the point of where there wasn't enough resistance to keep that spark energy going where you wanted it. It got a little hairy there for a while until they got it down and got it controlled. The solution for what they faced at the time was to make the distributor simply larger, which made it more difficult for that spark energy to jump internally inside of that distributor. We don't have that problem because we're firing coils directly into the spark plugs, very much like an automotive system. Which is derived from an automotive ignition system, a high-performance automotive ignition system. These coils or this ignition system is sometimes called a waste spark or a wasted spark system. What that means is when we're firing on the cylinder that's in compression, we are firing on the corresponding cylinder that's in exhaust. The cylinder that's in exhaust, the valves are open, the exhaust valve is open, there's no pressure in there. We can hit that spark plug with a high energy shot. There's no harm, no foul. From our perspective, we need to do it so that we can complete the circuit. The up benefit to that is that that spark plug that's in exhaust is getting a cleaning spark. So if there's any contaminants left over on the plug, carbon, whatever, from the previous power stroke, it's burnt off and goes out the tailpipe. The coils themselves, we like to see mounted on the firewall or a secure place in the engine compartment, not on the engine. The engine itself, we've never tested this with these coils mounted on the engine itself, like on the spine of the engine. The concern that we've got there is vibration. But if we get it onto the firewall or someplace after the engine isolators or the engine mounts, as it were, all of that nasty engine vibration is damped out and gone. Now, the nice part, particularly on Bonanzas, in many of the models, there is the avionics kidney panel that's on the left-hand side of that firewall. That is a great place to install coil packs. The other nice part about it is if you take the kidney panel off, you've now got something on the inside of the cockpit that you can mount the controller with. So it makes it fairly convenient for doing it. Like we can see here, there's kind of busy in that area. You might have to move some stuff around to get the coil pack on, but it certainly can be done. This is a coil pack installation on a Baron. This one was actually done in Australia. Pretty sure this is a 58P. Again, really nice install. It's going back to the installation manual where it says install this in accordance to part 4313. This is what that guidance in the installation manual allows you to do, is find the space, deal with the airplane that you're confronted with, and then get the parts installed on the airplane. Here's another example of an installation of a coil on a Bonanza. Again, in this case, it looks like they opted to fabricate a couple of extra brackets, which is fine. No harm, no foul there. The last piece of this we talk about in terms of the system components are the spark plugs and the spark plug wires. We get questions all the time. Daryl probably faces this almost on a daily basis. Which plug should we use? A massive electrode plug or a fine wire electrode plug? If I'm wearing my ignition system ball cap, I'm going to tell you that a spark plug is really providing us a gap by which we can throw energy across and ignite a fuel air mixture. If I switch my cap to my engine guy hat, I'm going to tell you that the plug you really need to let the engine do the talk. The fine wire plugs are designed for engines that have a propensity to either oil foul or lead foul. That's hence the reason for a fine wire plug. You've got less surface area there for contaminants to build up. That would be the real driving force. That and the fact that fine wire plugs, and I think Tempest, correct me if I'm wrong, Daryl, but I think Tempest warranties their plugs to TBO of the engine, we do use Tempest plugs. That's the company we've partnered up with. They build our spark plugs for us. They have them pre-gapped and they're ready to go out of the chute.
I'm not sure.
Um,
I'm not sure if
I
it's.
have not
you know,
recorded.
I would have to
Not
ask
sure
Vince that question.
if it's what the warranty limit on the fine wires.
Yeah. Yes.
The other question that we get, and I've seen a bunch of posts on this, and in Beach Talk, doesn't a fine wire plug give the engine better performance and all that? I'll be perfectly honest with you. I have never recorded any better performance from an engine moving from a massive electrode to a fine wire. That's from my perspective. I know the guys at ABS, Bob Ripley, he's generally promotes massive electrode plugs. Again, my point is the place I would fall to is let your engine do the talking. If your engine has a propensity of lead fouling or oil fouling, then a fine wire plug is a really good choice. Also, the useful life of a fine wire plug is much longer than a massive electrode plug.
And that's really the key thing that we talk about with customers when we're making decisions on spark plugs. Me personally, on my leaseback airplanes that are flying 75 to 125 hours a month, we run fine wire plugs. The reason being I've got some plugs now that have over 3,000 hours on them. That's fine wire. The massive electrodes, you're typically going to see 500-600 hours and they're going to need to be replaced. So what you got to look at, in the question that I ask the individual operator, are you flying 50 hours a year or are you flying 500 hours a year? If it's 50 hours a year, just don't spend the additional money. Put a massive electrode plug in it. If you're flying a lot and you want to get longer life out of the plug, it starts making more economic sense to go with the fine wire plug. Back when fine wire plugs were less than half the price they are today, it was a fairly easy decision to make to go with a longer lasting plug. But let's face it, now that these plugs are retailing close to $200 a piece, if you don't need them, if you're not flying a tremendous amount, don't spend the extra money. That's all I'll say on that.
I think that's all there is to say on that, to be honest with you, on spark plugs. I guess the other comment I would make too, to Daryl's point about the number of hours you fly and everything else, the one thing that will fail spark plugs faster than anything is contamination, buildup of either oil or lead or whatever. Do the maintenance on the plugs and keep up with them. I think typical maintenance intervals are 50 hours. Have them come out and get cleaned and check the gaps, and away we go. We do run with our system larger gap spark plugs. The gap is anywhere between 28 and 35 thousandths. Questions I get often is, will a magneto fire that gap? Not generally. It's going to be hard pressed to fire a gap that big. The other thing that you'll see is that you don't, generally speaking, you can't put these in a quote bomb tester, as they're called, and get a normal spark. The bomb tester just doesn't put out enough voltage at that point. I've got a note here about verifying proper spark plug hardware in the kit. Part of the sales function that Daryl goes through and the checklist that he goes through is he'll ask you a lot of questions about what's the engine part number, what's the timing set for, what kind of spark plugs are you going to run. If you're going to buy plugs, then we get that selected. As we build these kits, we have a worksheet that, if we know all this information up front, obviously there's two different sizes of spark plug hardware, and as we know that spark plug hardware, then we can make sure that the kit hardware that's in the kit is correct. You always want to double check the kits, really, of anything that you get, but we put a checklist in the front of the installation manual to make sure that you got all the components in the kit that you're supposed to have. There is absolutely nothing more frustrating than getting halfway through the installation and discovering that you're missing a part or that there's an incorrect part in the kit. We are only human. We have some defaults that we go to if we don't know what you're actually installing on the airplane. Again, in this group, in this community, pretty much you're all running big barrel spark plugs anyway with the Continentals. I can't think of any applications where they're running small barrel typically, but it's just a good practice to have. The plug wire that we use is referred to as a spiral core wire. It is a hot rod spark plug wire. It's a has, if we think of the construction of it, moving from the inside of the plug wire out, it's a non-conductive center that has a very fine stainless steel wire wrapped around that non-conductive core. And then the outer jacket is 100% pure silicone. A typical magneto wire, and by the way, we're running 8.5 millimeter diameter wires is what we run. That's just that much more silicone to protect the conductor of the wire.
And
Aircraft wires.
by the way, the picture of the wires here, those aren't the right wires. You need to change this picture, Mike.
Well, I get reminded of that and embarrassed every time he says it. Yes, I know they're red wires now, as opposed to they're actually a nice burnt orange. They're a nice burnt orange wire, Daryl.
There
Just for
you go.
I
There you
did that
go.
just for you. I hope you're happy.
Very happy.
We use an 8.5 millimeter high performance race car wire. Again, it's a spiral core wire. An aircraft magneto wire is a 7 millimeter solid core wire. And the construction, again, starts off with the very center as a solid core. There's then a nylon, it's not 100% silicone. I don't know what the material is, but a nylon plastic jacket on it. Then you get another outer jacket, a thin jacket, like a heat shrink. And then on top of that is a steel braid that's grounded at one end for noise suppression, and then typically another jacket on top of that. Magnetos, because they are low energy devices, that outer steel braid is sufficient for the noise suppression of it. When you go to a high energy system like ours, that outer steel braid becomes a ground point. Voltage or electricity is always going to find its way to ground. And over time, and it's frankly over a very short period of time, the energy as it's coming down that wire through a high energy system is going to begin arcing to that outer steel braid, and it'll arc and you'll pick up radio noise. That'll be the buzzing that you hear in your headsets. The automotive industry, when they came out with high energy ignition systems, went to a spiral core wire to get away from that failure mode that they saw on the spark plug wires. If anybody can remember the very first composite car that had a high energy ignition system, that was the Chevy Corvette. Since it's a fiberglass body, there's no natural ground plane for it. And when they put the high energy ignition systems on it with the conventional automotive plug wire, which is our 7 millimeter wire today, they ran into all kinds of radio noise problems for the AM FM radio. Going to the spiral core wire eliminated that. And one of the big things that you can see in a spiral core wire, and a way to check it, is that there's a resistance measured per foot. The wires that we supply with our kits have a resistance of 5,700 ohms per foot. The higher the resistance, the better the noise suppression in high energy ignition systems. We do send the wires in the kit so that they can be assembled when the kit is installed on the airplane. The simple reason for that, we have no clue where that coil pack is going to go, and therefore no way of knowing how to build the wires. Again, remember, the kit is designed and the installation manual designed so that you can install it on the airplane that you're facing. There is an online video that Daryl did. He's stepped away, I think, for a minute, but an online video that Daryl did showing how to do the spark plug wire assembly. It seems finicky, and I guess it is, but once you see the video and you get the hang of it, it's pretty straightforward. It shouldn't cause you a lot of problems. The other thing with a high energy electronic ignition system that you really want to get to is you want to have proper spacing between the plug wires. We like to see about 1/4 of an inch of spacing between the wires. This prevents what's commonly referred to or affectionately referred to as crosstalk. If you were to bundle the wires together in a bundle and just zip tie them together, like you see quite often in a magneto situation, what ends up happening is that energy, as it's passing by each other, well, it's going to draw towards each other, and it's going to naturally try to jump from one wire to the other. In really bad cases, it'll actually shut the whole ignition down. We had dual systems installed on if you remember, the Liberty XL2, a little 2-seat composite airplane that was used in the training world. That owner, that particular airplane, the wires were all bundled together, dual system, and it wouldn't run. So once he got everything separated out, the ignition system ran great. You can see here in this picture, the spark plug wires running to all the bottom plugs and pretty good wire spacing there. That's a nice install. Speaking about bottom plugs, we get the question all the time, which plugs do you want our electronic ignition system to run to? Truth of the matter is, we tell you to run them to all the bottom plugs. Bottom plugs follow first. Gravity works. So all the stuff in the cylinders will fall to the bottom and can corrupt the spark plugs at the bottom cylinders. Now, having said that, the wires that come in the kit are plenty long enough to run to all the bottom cylinders. What ends up happening, though, is the magneto that you leave behind, if you remain with one magneto, one electronic ignition, you've got to make sure that that harness will go to all the top plugs easily. I will tell you, if it doesn't, don't fight City Hall. It is just too hard these days to get a half a harness. Do the conventional setup, 3 on the top, 3 on the bottom. There's been a lot of discussion about, well, shouldn't you have a split system, 3 on the top, 3 on the bottom, that sort of thing. The best that we could find, and we did a lot of research on this, quite frankly, is that the reason the magnetos were set 3 on the bottom, 3 on the top was out of tradition. There is no technical data that we could find, and there may have been at one point in time. My guess is it's just been lost to history, but there was no technical data that we could find that would separate that would require the need for 3 plugs to be wired on the top and 3 plugs to be wired on the bottom. If you look at the E-Series engine, the older Continentals, the E-Series, or the 0300, those engines are 1 magneto is wired to the bottom and 1 magneto is wired to the top. Unfortunately, that's the best answer I can give you on that kind of a scenario. Moving on, we also have, and again, by the way, people have questions. If you want to chime in on the chat thing, it pops up on my screen. I'll try to answer it as best I can. A group this big, until we get to the end, it's probably a little difficult to field a bunch of questions at once. We have what we refer to as the key switch replacement, or our ignition switch panel. This is designed to replace rotary key switches, which are absolutely the bane of my existence. I hate those things. They are terrible. The design of them is terrible. They are a rotary key switch, as they're used in airplanes today, are a ground path switch that is normally open. So if you think about it, when the key switch is in the both position, there are 2 switches inside of there. Those switches inside that rotary key switch are open. When you select left ignition, which, has anybody noticed that that's actually on the wrong side of the key switch? That's on the right-hand side of the placard. But when you select left ignition, what happens internally in that key switch is the switch for the right-hand magneto closes. So the P lead that's attached to the rotary key switch is now, the switch closes, and that P lead is made a contact to the ground post on the battery. That's why we call it grounding out the magneto. The magneto itself continues to produce energy, but instead of going through the distributor out to the spark plugs, it goes through the P lead to the ground post on the battery. We've grounded it out, and effectively we've shut off the magneto. When a key switch is used with an electronic ignition system, what we are grounding out is the signal being generated by, if you remember several slides ago, the trigger mechanism, the mag timing housing. Again, that effectively shuts off the ignition system. So when we go back both, what happens internally in that switch, now the switch path opens up and the signal, instead of being grounded out, is now generated again. An electronic ignition system, and it really doesn't matter which one you use, needs to locate itself in the firing order. Once it locates itself, which is about a revolution or 2, then it'll start firing again and go. If you have depending on how snappy the rotary key switch is, depending on your own particular technique, if you're moving from both to left to right, instead of coming back to both like you should, but if you're moving from both to left to right, and you stay too long in the left position, or you loiter too long between right and left, now both ignition systems are off, both the magneto and the electronic ignition is off, fuel's building up. So when you go back to right and that ignition hits, you run the risk of a backfire. The other problem that we've seen with rotary key switches, and just had this happen the other day, is if the switch itself is not very snappy internally, if it's not been serviced, a whole variety of things, the key switch will start to arc. You'll start to have little arcing internally inside of that key switch as it's trying to find ground. Again, it's seeing the P lead and maybe trying to find ground. That will also interrupt the signal being generated from the mag timing housing, and will cause the mag timing housing to kind of turn off and turn on, turn off, turn on, turn off, turn on. Often when we're doing troubleshooting and we have that kind of a problem, first thing we do is we have the shop disconnect the electronic ignition system from the key switch and see how it runs. And 9 times out of 10, we found that that takes care of the problem. So the evolution of this was we developed our own ignition system switch panel. In this case, as you can see, on the left is a magneto switch, on the right is the EIS switch. The other thing that this does just by nature is it forces you as the pilot to slow down during your ignition check so that you can actually observe the RPM drops and then have the engine come back on with both ignitions on, normalize itself back to the run-up RPM. Just in anticipation of a question, with the Electroair system installed, we do expect you to see different RPM drops than what you had with both magnetos. You're also going to see probably less fuel to get up to your engine, or to get the engine up to the RPM where you would do an ignition check. Again, the reason for that is a much more efficient electronic ignition. So what we expect during the ignition check, you bring the airplane up to say 1700, 1800 RPM, you turn off the magneto. We do not want you to see more than about a 30 to 35 RPM drop when you're on the electronic ignition alone. The closer you get the ignition system to TDC and tuned to the engine, the more likely that RPM drop could very well be 0. No RPM at all. No RPM drop at all, that is. The electronic ignition, our electronic ignition, because of the high energy coils, is capable of firing off that fuel air mixture and completing the combustion event inside of the combustion chamber. Go back to both, turn the electronic ignition off, and see and observe what the drop is going to be. You will see a typical magneto drop. You may even see a drop that's higher than what you had before. Simple reason for that is, again, you do not need as much gas now because of the electronic ignition to get to your 1700, 1800 RPM number to do an ignition check. Less fuel, you're on the magneto alone, gonna result in a larger RPM drop. Perfectly normal. When you do the installation, as part of the post-installation checklist, is you actually record what these drops are going to be in your checklist somewhere, so you know what you're looking at. You're no longer looking for the differential because the differential just isn't there. The differential with the electronic ignition system is going to be substantially huge. What the differential tells you with the magnetos is if you're starting to see a problem. When you do a mag check right now, you're looking to make sure that the magneto is running, but you're also looking to observe what the RPM drop is and what the differential is. Right now, if you shut off one magneto and you get 150 RPM drop and the engine's running rough, that's telling you you've probably got a bad plug or a bad wire. If you get, again, same scenario, 2 magnetos, you drop one magneto off, and the differential gets to be really big, larger than, I think normally it's allowed 75 RPM differential, it tells you that the timing of the magneto is off and needs to be looked at. Case of the electronic ignition system, same thing, is if you shut one or the other off and you get a big drop in a rough running engine, that generally points to a plug or a wire. If you get a big drop on one or the other and it's really smooth, larger than what you would normally expect, that's going to point to a timing problem on one of the other ignitions. This allows you, the ignition switch panel allows you to proceed with the pre-flight checklist, the engine run up, performance slower, not that, I mean, you're not losing any time necessarily, but to really understand what's going on. We do make these switch panels if you don't have an electronic ignition system, but you want to get rid of the rotary key switch, which has a recurring AD note. These do not. We make them for 2 magneto situations as well. Now we're gonna move on to have a little discussion about dual systems versus single Electroair systems. I think Daryl may have mentioned at the beginning, and if not, I'm gonna kind of reiterate it right now. For the Bonanza Barron community, to be real honest with you, we're not a big proponent of dual electronic ignition systems. There's just not that much benefit by going that route. We often say when we're at trade shows, if you think of a scale from 0 to 100, 0 being 2 magnetos and 100 being 2 electronic ignition systems, you get about 90% of the way there with the first electronic ignition system. You get what I call the wow factor, the big pickup in fuel savings, the smoother running engine, the improved airspeed in many applications. All that sort of thing comes with the first Electroair system. The second system, the dual systems, you might see slightly better fuel savings, especially if you go up in altitude, meaning 15,000 feet and above. And you do end all magneto maintenance. There's no question about that. And given the prices that have changed over the course of the last few years and in mag overhauls and such, it might make a strong case for it. It really just dual systems, particularly in the Bonanza and the Barron community, it just really depends on what your goals are. If your goal is to get rid of magnetos entirely, we're happy to help you out. But the reality is, and just being completely honest and straight, we think that your best bang for the buck is just doing a single system. Where a dual system is required goes back to the discussion about Bendix single drive dual ignition systems. We just don't have a choice. The way we've got our STC written is it's done such that we can have dual electronic ignition systems. There was, in neither case, the 4-cylinder or the 6-cylinder applications for that Bendix dual mag, was there a drop-in single magneto that could replace it and just go? We looked. And frankly, we looked pretty aggressively. With dual electronic ignition systems, dual Electroair systems, there are some backup power requirements that have to be in place. The first one is a backup alternator. That is one option. With a backup alternator, whether it be a B&C that's off of the vacuum pump drive, or I think there's a Hartzell one's got one as well, same thing. You would wire one of the electronic ignitions directly up to that backup alternator. Now, in the case of the B&C, I can't speak to the Hartzell so much, but in case of the B&C, what that does mean is that you have to have that backup alternator running during the flight. Needs the field to be excited, and it's running. Everything is diode protected, so you're not backfeeding into the other alternator or overcharging the battery or anything like that. But the way the FAA designed their guidance letter to us as far as backup power requirements, when using the backup alternator, you need a seamless way that if for some reason you lost your entire electrical system, that at least one of the ignitions is wired to a standby power source or a standby alternator. The other way of doing this, of backup power, and this is the more common way to do it, is to use a TCW backup battery. It's a lithium iron battery. They're very commonly used in a lot of avionics applications, and it's a small, nice, compact battery. In a 12-volt application, they've got a 3-amp-hour battery and a 6-amp-hour battery. In a 24-volt application, they have a 3-amp-hour battery. The TCW battery, if that's the pathway you're going to go with dual Electroair systems, one of the electronic ignitions has to be wired to the backup battery and then nothing else. The backup battery is dedicated to backing up that one Electroair system. The TCW battery has logic built in internally. It's monitoring the electrical system of the airplane. Once it falls below a certain level, then it automatically locks out the device that's connected to it, in this case, the Electroair system, and then runs the Electroair system off of that battery. The FAA requirement was that we had to be able to run one Electroair system for at least a period of an hour before it ran out of gas or juice, if you will. The 6-cylinder system in a 12-volt application draws about 1.25 amps. So a 3-amp-hour battery will drive an Electroair system for at least 2 hours, probably a little bit longer. 24-volt system, again, the TCW battery is a 3-amp-hour battery and 24-volt application, just for rounding purposes.
we budget for an amp draw on the Electroair system upwards of 3 hours. Also, what comes along with the TCW battery is you have to have a backup battery panel that's monitoring the backup battery. This gives us the voltage information. It also gives us an amber light to tell us when the backup battery is in use. So pre-flight or post or pre-takeoff, you make sure the backup battery system is in the ready position. You'll have both EIS, if you're running dual systems, again, EIS1, EIS2, those green LEDs will be illuminated, and then there's a voltmeter there. If the electrical system of the airplane just goes away, poof, disappears, that little amber light will come on because now the TCW battery has locked out the aircraft electrical system and is now driving the electronic ignition system. The TCW battery logic, it continues to monitor the aircraft electrical system. So if for some reason the aircraft electrical system heals thyself, it will then, and rises above the threshold voltage, it will then turn the backup battery off. It'll reconnect the electronic ignition back to the primary electrical system, and then it'll also take a charge off the primary electrical system to recapture or get back to where it belongs. The battery in use light will also go out. Attached to this is also what, for the dual systems, is a TAC relay box. Both electronic ignitions generate their own TAC signal. It's a square wave. Most every electronic engine monitor system that I'm aware of can receive the electronic signal from our TAC. The JPI 930 needs a conditioning box of some kind. The older JPI units will take the signal directly. Depending on Garmin equipment, there is either a setting that you set up in the Garmin equipment or the Garmin stuff will take the signals directly. But most of these engine monitor systems can only receive one single electronic TAC input. We have a relay, obviously we've got two electronic ignitions, and that relay will toggle. You'll have a primary TAC signal going to your engine monitor, but for the purposes of doing an ignition check, it'll toggle between the two so that you've always got an RPM reading. When it does toggle, we've seen this on a lot of Garmin stuff, what you'll see with the display is the display will read nice and steady, and then when you toggle between the two, it'll kind of bounce around a little bit, and then it'll settle back down. A relay obviously is a mechanical device. It's how the logic within the Garmin system works. I do believe the JPI system works very similarly. And again, the backup battery panel has two indicator lights for the electronic ignition. Those indicator lights are actually monitoring the RPM signal. We know that when the RPM signal stops from the electronic ignition, that the ignition itself is no longer producing a spark. So the green LED is monitoring that signal and will go out when that TAC signal ends. There are, if you go with a dual system in particular, you do get into a lot of paperwork as far as STCs go. The ignitions themselves have an airframe and an engine STC. That's a requirement of the FAA. The ignition switch panel has its own STC. We recommend the ignition switch panel in all these applications. The battery backup has an STC, and the battery backup panel has its own STC. And as I put there, it's coordinated with the backup battery. A lot of questions as to why that is. Got to be honest, you got to go ask the FAA. The reality is this is how a lot of these projects evolve, and it was the simplest way to get things done, believe it or not. It shouldn't be intimidating. We've got lots of help that can help your technicians get the paperwork done, but there is some paperwork involved, obviously. The last part that I'm going to talk about tonight has to do with the instructions for continued airworthiness. We have pretty much all of our technical data or documentation online, from the installation manuals, from the approved model list, the aircraft model list, to the operational instructions, the flight manual supplements, the instructions for continued airworthiness. Inside of the instructions for continued airworthiness are all the troubleshooting steps that you would follow in Chapter 5. The question we get quite often, are there a lot of required maintenance intervals or parts? And the short answer is there really isn't. What we like to see is spark plug wires, to have those replaced every 5 years or 1,000 hours in service. Silicone wires, because of the nature of silicone wires, as they age, they will age harden over time and they will crack. And you can get arcing coming out of the plug wires. Far as any of the other components go, the mag timing housings, I think they've got Daryl's at what, 2,400 hour TBO, I think, on the mag timing housings.
25.
And then the other components just are on condition. If you have a prop strike, the mag timing housing has to be replaced. That's just mandatory. The things like the controllers and the coil packs, those just go on to condition. There are no real inspections for, say, an annual inspection, other than just to make sure the connectors are in good shape, you know, that they're still tied together and everything's well that way. Really, the idea behind it is that it should be, all things being equal, fairly maintenance-free once it's installed. Some of the things that we do see that are troubleshooting questions that come up fairly frequently, this would be an example of the spring not being inserted correctly in the spark plug wire. As I mentioned before, the core of the spark plug wire is actually is a spiral core, so there's a non-conductive center, and wrapped around it is a very fine, tiny wire. And then as you're building the plug wires up, you cut them to length, put the hardware on them, and then there's a spring that gets inserted into the plug wire along that spiral core. And it's really important that the tail of that spring stay in contact with that spiral core the whole length of the tail of the spring. Because if you don't, if you end up in this case, got the tail now going in at an angle, or it gets deflected in some fashion, you've got that tail sticking out of the plug wire, it's going to arc to the top of the spark plug, and it's going to misfire on that particular cylinder and cause a rough running engine. Another thing that we've seen, a couple of things here, the picture on the left, the installer here put the controller in the engine compartment. The controller is not designed to be in the engine compartment, both from a vibration standpoint, but also more importantly from a temperature standpoint. The electronics do not like the temperature environments in the engine compartments. The controller is rated up to 150 degrees Fahrenheit. What you design for on the back of the engine is 180 degrees Fahrenheit. We do get questions about the coil packs from time to time about temperature limitations on those. These epoxy molded coil packs are good to a temperature range of about 350 to 400 degrees Fahrenheit. If you have a problem with the coil that's temperature related, you've got probably another problem entirely. I've seen an installation in particular where it had to be a leaky turbocharger, and the coil pack plate was resting on top of some ductwork and ended up being a heat sink. And it got so hot on that coil pack plate that the anodizing just faded away, and it did cause the coil ultimately to misfire. The other condition that would cause the temperature to go up very high like that behind an engine would be an engine fire. Again, entirely different problem than you're not worried about an ignition at that point. You're more focused on putting the airplane on the ground. The picture on the right has to do with spark plug wire spacing and looping. This engine did not run correctly because of these spark plug wires being looped and bundled together. They've got to be separated as best they can. Ideally 1/4 inch. This is another thing that we see fairly often, are high energy spark plug wires running next to signal wires. And again, or even onto starter wires. You don't want that signal wire that's on the trigger mechanism to be running in with a high energy wire. It's also part of Part 43.13 in terms of wiring, about keeping signal wires separate from high energy wires at all times. We can shield them as best we can, but it's still good practice to keep those wires separated. And finally, post-installation stuff, we really want you to go through the flight manual supplement and understand the procedures for doing the ignition checks. It's a good brush up for everybody. Use proper engine management techniques. I would review this stuff with your technician. They are your best resource for how that engine should be operated and understanding how Continental Motors should be operated. We also want to go through starting and shutdown procedures. Explain why when you're doing a shutdown that there is an RPM rise during the shutdown. If there isn't, that means the engine is probably set too lean. That can point to an induction leak or a fuel system problem. Mentioned it before, Daryl will probably reiterate it as well. One of the things that is true about this ignition system is that it is removing the weakest link of the propulsion system of your airplane. And that weak link is the magneto. The minute you remove a weak link, what happens is you expose the next weak link. Fuel system setups are a very common problem we run into. Induction leaks are a very common problem we run into. Baffling, we run into that fairly frequently. All of these things that really it can be masked by a poor ignition system are now exposed by having a very high energy, variably timed ignition system. I think that's my last slide. Daryl, have you got anything to add?
Probably the only thing that I would add at this time before we kind of open up to as many questions as people want to ask. Just in full transparency, you know, and it was talked about on Beach Talk, I know, and I've seen it in other forums as well. Electroair had a problem late 23, early 24 with the 6-cylinder mag timing housings. Realized it pretty quickly. It took a little bit to figure out what it was. It actually took Mike calling in pretty much everybody involved in the manufacture of that piece of equipment, which is probably the most, without a doubt, the most expensive part of the entire system is the 6-cylinder mag timing housing. Called everybody in, from everybody that supplies the materials used to make the gears to the shop that makes the shafts, the shop that builds the housing. Long story short, they quickly isolated the problem. Was the original drawing for the housing itself had too large of a tolerance between the two shafts. We rocked along for better than 10 years with zero problems with the 6-cylinder MTHs. Then all of a sudden we started seeing gears disintegrating. What happened was the shop that makes that housing had gotten on the other end of that tolerance, and now the gears were too close together. That has all been corrected. Turned out to be actually, even though it was an expensive problem, turned out to be a really good drill in learning with the material manufacturer of the gears. Actually came up with or suggested a little bit different material for the gears. We've got the tolerance now corrected on the print. The inspection procedures are now a little bit different when they receive these parts. Since all the changes have been made, we have had absolutely zero problems with the gears and the mag timing housings. Very happy to report that. I know it got talked about, but I just wanted everybody to know that it was addressed very methodically, and actually more than just one improvement was made in that particular unit. And they are, once again, an extremely solid unit. I mean, I've literally had MTHs replaced after over 4,500 hours of service. And that's pretty impressive. One thing I will quickly say while we're talking about mag timing housings, remember these mag timing housings are attached to the accessory case. A lot of people know, a lot of you probably don't know, I spent 35 years in the aircraft propeller industry, owned my own shop here in Houston, and I used to do a lot of dynamic balancing of engine prop combinations. When you have an imbalance, and it doesn't necessarily have to be something that you can feel in the pilot seat, but those frequencies can be transferred to the accessory case and really wreak havoc on accessories. I can't stress enough the importance of keeping up with having your dynamic balancing done. That's not, to me, it's not a one-time thing. The reason it's not, I used to tell my customers, I don't care if you let me do it or somebody else do it, annually is a pretty good idea for a dynamic balance, because things are going to change in the engine over time as things wear, but also you never know what filing is going to be done on your propeller blades during an annual inspection, or if you do it yourself, you pick up a nick and you dress it out yourself. That changes the whole parameter of dynamic balance. So and it's one of the cheaper things that you can do with your airplane is having a dynamic balance done. Can't stress that enough. On occasion, we will see a leak in an MTH, and I would be willing to bet 95% of those are truly a function of vibrations being transferred into that shaft on that MTH. I mean, I've seen magnetos taken out because of it. I've seen especially starter drives taken out because of the vibrations being transferred, in particular off of the prop. So just something that doesn't often get thought about, but it's money well spent over time as far as saving the integrity of really your entire airplane. Vibration is just a bad thing. It tears up everything. Other than that, Mike, I don't really have much to add. I did want to talk about the MTH and that problem has been resolved. I'll leave it up to you as far as opening up to questions. I don't know if you've received any chat questions or anything like that.
I did, Daryl. In fact, I might even let you deal with this one too. By the way, if while I've got this slide up, I mean, Daryl will announce his phone number once we get to the end of it, but probably a good time to jot contact information down if you've got a pen and paper. One of the chat questions that came through, Daryl, was, can we talk about a comparison between us and the SureFly system?
That's an actually pretty easy one. And first and foremost, I will tell everybody listening that we know the guys at SureFly well. They're friends of ours. We all get along. But really, you're comparing apples and oranges. They're two totally different products. SureFly chose the route of a very simple drop-in ignition to replace a magneto. And that's what they talk about. If you go talk to them at one of the shows, when people ask, are you better than Electroair? Well, they tell them it's easier to install. What you really got to focus on is what are you trying to achieve by converting your airplane from traditional magnetos to an electronic ignition, and more importantly, an electronic ignition system. That word system is very important. I think Webster defines a system as anything that's made of multiple components to achieve a goal. The Electroair system is a system. You've got three major components: a controller, which is the brains, it's actually the computers. You've got a high energy coil, and then you've got a trigger mechanism, whether it be a mag timing housing or a crankshaft trigger wheel. It's those three elements that are all tied together via wiring. And then, of course, our high energy spark plugs and our special spark plug wires that create this system. The goal of this system, and Mike mentioned it early in the presentation, we're not about just replacing a magneto with something different. We're about performance. We're about taking you from point A to point Z when it comes to what you can achieve through ignition. Unfortunately, none of us are probably going to live long enough to see the aircraft engine manufacturers incorporate high energy ignition systems into their engine designs. They don't have the engineering budgets to do it. What Electroair has done is given everybody an opportunity to bolt on a high energy ignition system, basically an HEI system that was derived, quite frankly, by the automotive industry. The original founder of Electroair, Jeff Rose, was a gearhead muscle car guy, but he also built experimental airplanes. He just could not understand why he knew how good the ignition systems were in the automotive industry. Why couldn't he use them on his airplane? Well, he did. And that's how Electroair was born in 1992, 33 years ago. Electroair's been around a long time. So you've gone from a traditional magneto, again, very weak energy output, very short spark duration. They've served us well. Nobody can argue that. But there's obviously a much better way to get it done. And the Electroair system is the answer. Again, if you're looking for performance, if you're looking for fuel savings and a definite return on investment, that's what I always look for on my own leaseback airplanes. And when we're spending money, whatever we're doing, are we going to see a return on an investment? Obviously, there's things you have to spend money on because it's a maintenance issue, something that's got to be done. But if we're looking at upgrades, I'm always looking at return on investment. We have seen a huge return on investment because all of our airplanes, and we have 172s, Archer 2s, a 200 horse Aero that are operated in a large club down here in Houston. We have seen a massive return on investment with our Electroair systems. One less magneto to maintain, and the fuel savings. The fuel savings have been significant enough that the fuel supplier on our little airport actually called my business partner last year to ask if there was something wrong. Our fuel cells, their fuel cells were down with us, and we're the largest purchaser of fuel on the airport. And my partner Kirk said, no, actually, we've added more airplanes and we're flying more hours now. And they're like, well, are you buying your fuel somewhere else? Well, no, we're still buying it all from you. But all of our airplanes have Electroair systems installed, and almost to the man, the other, I think 15 airplanes that are leased back to the Aero Club have all had Electroair systems installed. So the amount of fuel savings is significant. The big thing for us, and for people that know me, I am anal to a fault when it comes to aircraft maintenance. I mean, I spent 35 years of maintaining aircraft propellers, and I'm very proud to say that had 0 incidents, not one, 0 failures, not a single problem. And the reason is because I was taught well when I was young, if you're not comfortable with it and the manual doesn't support your decision, don't do it. Period. With that said, my business partner on my leaseback airplanes, and it took him some time, convinced me that we could run our Lycoming 360 engines beyond TBO. And we started out small, couple of 100 hours, couple of 100 more hours. I can honestly tell you now, we run our engines 3,500 hours and they're still strong, but that's where we draw the line in the sand. At 3,500 hours, roughly, they come off and they get sent to the overhaul shop. I'm fully convinced that one of the reasons that we're able to achieve that safely is the fact that we have Electroair systems installed. These engines run much smoother. They run much cleaner, much more fuel efficient, and it just adds up over time. And again, like we talked about earlier, that reduced temperature on the exhaust valve is huge because we're getting that fuel consumed in the combustion chamber, not in the exhaust pipe. And for you guys that have power flow exhaust systems or the DeShannon exhaust system, tuned exhaust of any kind, if you're not running a high energy ignition system like Electroair, you're going to wear out your exhaust valves even faster, because now you're accelerating the speed at which that plasma is passing across that exhaust valve. Exhaust valves were designed to handle spent gas, hot gas, not burning fuel. And the #1 cause of premature cylinder failure is, without a doubt, exhaust valve failure, either valve seats or valve guides, or a combination of both. Again, back to the original question, Surefly versus Electroair, 2 totally different products. They can't compete with us when it comes to a high energy, long duration spark. Physics can't be overcome. They can't get a coil big enough in a housing the size of a magneto to get that big high energy spark. Am I going to sit here and tell you it's a crappy product? Absolutely not. I don't operate that way. Is it better than a magneto? I would certainly hope so. Is it as good as Electroair? Not even close. I'll end with that.
Daryl, if I can jump in here, question, there's 2 questions I want to address. I'm going to address them in kind of backwards order because you just got done talking about Surefly. Customer Joe said, so are you saying that a Surefly is simply an electronic mag, no performance benefit? And I would have to piggyback what Daryl said. Yes. I mean, their design goals, their engineering goals were somewhat different than ours. They wanted to achieve an ignition that would operate 2,000 hours without maintenance and without overhaul. And I would say that, you know, based on what I'm aware of with their system, I would say that that's true. Is it better than a magneto? Gosh, I hope so. I know that some customers have reported some operational benefits, but Surefly as a company corporately doesn't promote them in the same fashion that we do. And Joe, I hope I answered your question, or your question got answered. If you've got more, please feel free to type it in. The other question that came through while Daryl was talking is Electroair works good on 12-volt systems. What's being done to improve 28 volt, or really 24 volt systems? Our system works good on 24 volt systems. I know that Surefly had some issues early on with 24 volt systems. And the best way I can explain that has to do with not the coil, but the actual controller or the electronics of our system. So at the heart of it, the controller, if you pop the cover off, you're going to see a printed circuit board with microprocessors on there and a lot of other electronic components and stuff. We have a DC to DC voltage regulator there that will take voltage from as low as 8 volts and as high as 33 volts, and it knocks it down to 5 volts to drive the components on the board. Actually, it knocks it down as low as 3 volts. Some of the components on the board now are 3-volt components, believe it or not. So our voltage range, and this part of the Surefly system I'm not that familiar with, but I can speak to ours. We have a pretty broad voltage range. And if you're talking about 28 volt systems, what a 28 volt system is, it's charging a 24 volt battery. And that 28 volt alternator can have a range or a tolerance that kind of bounces around just by the nature of it. And I believe that some of the problems that have been run into before was where that voltage crept up to 30 volts. Most DC to DC converters have a top range of the standard ones, if you will, have a top range of 30 volts. We selected one that's got a 33 volt top range, and that should address all of the problems, or the potential problems that you have, I should say, on a 24 volt airplane. Other than that, if we get into voltage problems that are related, and actually we should speak to starting issues here in just a second. If we get into voltage problems, that now gets a little bit more fundamental into looking at the electrical system of the aircraft. Oh, and thanks, Joe, for the comment. He made a comment back saying, yes, thanks, I appreciate I have a single Electroair systems on his 58 bearing. So great, thank you. One of the questions or comments, Daryl, I think you had seen had to do with starting issues. Now, starting issues on a variety of airplanes we have run into, but most of the time what we find, and we try very hard to work with the technicians to collect the information and go through it. Starting issues, let me speak to how the Electroair system works in the starting sequence first. We have an RPM floor below which our system will not fire. In other words, from 0 to about 50 to 60 RPM, our ignition system is not firing at all. And the reason for that is because of our 60-2 tooth trigger wheel. If you look at what's happening in the engine in that very low RPM band, the acceleration curve of it when the starter engages the engine is very ragged. It's bouncing around like this as it's starting to move up. At about 50 to 60 RPM, that acceleration curve smooths out and we get a nice parabolic shape on the curve. The electronic ignition can then come in and start firing. That real ragged edge at the beginning has to do with the compression strokes of the engine. So as the engine's going around, boom, like that. On an electronic ignition system like ours, that trigger wheel, you run the risk of it moving backwards. And a microprocessor can see that, if you will, and it screws up the firing order for the electronic ignition. So the 50 to 60 RPM point is the limit, or the bottom end of the limit. Once you achieve that number, now it's a nice smooth acceleration curve. You've overcome the compression strokes and away you go. So if we run into starting issues, often we're going to look at the RPM first. We're going to want you to send us a video, frankly, of outside of the airplane so that we can see the start sequence and we can watch the propeller going around. With cameras today and the phones, we can slow that video around and really call out what the RPM is at that moment in the starting sequence. I know everybody wants to look at their TAC on the JPI or the Garmin. The truth of the matter is that signal is an average, and down at those low RPMs, it can be very inaccurate. We've had some people see on their electronic TAC that the engine was spinning at 120 RPM, but when you look at the video and slow it down and actually count blades, according to the timestamp on the video, it's more like 40 RPM, and it's just moving too slow. The other issue that happens during the start sequence quite often, this is particularly prevalent with high energy starters or high torque starters, is that the voltage of the airplane can go way down. Now, again, we're looking at our engine monitor and we see a voltage that says the voltage is 12 volts or 12.4 volts. We have to remember that that voltmeter on that engine monitor is taking an average. It's sampling maybe every 6 revolutions, maybe sampling on a timestamp basis of once per second or something, and then it's taking an average, and that's what it's displaying on your engine monitor. Again, at that start sequence, it's really, really inaccurate. To look at the voltage properly, you really want to have a voltmeter that has what they call a max-min function, in a way of being able to measure the instantaneous max voltage and min voltage during a particular run. That's helpful. If the voltage falls below, our system will go down to 8 volts, but we have to remember that that's on a test bench. What the system sees on an airframe can be dependent upon the age of the wiring, how everything's connected, what's drawing down, and a high torque starter will draw the voltage down even more significantly. So those are the things that we look at during the start sequence. The things that we end up seeing that are changed is the condition of the battery. It may volt check correctly, but you really want to look at the cold cranking amps or the capacity of the battery to make sure that it's actually outputting the amperage that you need for the starting sequence. Starting solenoids are another one that's a really neglected part that over time, they just wear out internally and they can drop the system voltage down considerably during that sequence as well. Starters, that's another one. Nobody likes to hear that, but as starters wear out, they draw down the system voltage as well, or they just simply turn slower. The original, I was telling this earlier today, the original lightweight starters were all based off of a Ford Mazda starter that was used to start an engine in a Ford Escort, for those of you that remember those. I would often joke that Ford Escort engine, you could look at that thing and it would start going. Aircraft engines inherently don't like to start. They got to get cranking, and you're dealing with the proper fuel mixture and the air mixture and everything else. So those are all, we run into starting issues on a semi-frequent basis, and we try very best to get our troubleshooting people on board, collect a bunch of information, and see if we can't get you down the right pathway. One of the other things that we've seen, and I got to be honest, Daryl, I don't know if EarthX has got an approval on the Bonanza and Barons yet or not.
I recently learned they do not have the approval, but they are actively working on it.
So one of the big advances, frankly, in battery technology that should hopefully be available to this community soon is the EarthX lithium iron battery. That battery is a really kick butt battery. It's super lightweight, and the voltage profile, as you look at it, when you engage that battery, it has a profile a lot closer to a NiCad battery. So if you think of a XY curve and you're looking at a standard lead acid battery, the minute you engage it, that power starts to come off in a nice parabolic curve immediately. In a lithium ion or a NiCad battery, that power stays flat until it's done, and then drops off like you're falling off a cliff. But it gives a nice steady voltage output during that start sequence and really works very well. They've had a lot of success with them on Piper Lances and the PA32 line. So hopefully that'll be something else that, and again, we kind of have to think about this and remember that the Electroair system is overlaying onto an airplane that was never designed for an electronic ignition system in the first place. And if we dial the clock all the way back, we begin looking at how these systems were designed. And unfortunately, for a whole variety of reasons, as improvements were made, lightweight starters, electronic ignitions, nobody talked to each other to take a look at the whole power distribution system of the airplane. If we were in the automotive industry, my gosh, you have entire committees dedicated to that kind of stuff to make sure that they get it right. Another question, I know there's a question about a DMAG. I'll come back to that in a minute. 12-volt system has spike protection, as you mentioned, a 30-volt protection. The same protect the alternator spikes for 20-volt systems. Again, is there any work being done any current work being done to increase 24-volt spike protection? No, I mean, we're up to 33 volts. I haven't run into enough problem. I haven't run into any problems that I'm aware of at any rate on 24-volt systems. That's a question from Warren. Warren, that may make sense for you to give me a call tomorrow at the office or send me an email, and we can talk about it a little bit further, because I think I'm missing a part of what the question that you're asking for. And I'd like to address that a little bit more closely. The other question that we got is to talk more about the DMAG, that it requires 2 complete mag sources. Well, so on the DMAG or the dual mag engines, what our SDC requires is that you install 2 electronic ignition systems. The original history on the dual mag ignition that we looked at is we tried to find a magneto that would drop in and replace the Bendix dual mag, knowing that we would drive one of our electronic ignition systems off the crank position wheel on the front of the engine. It just doesn't exist. And it's worse in the 6-cylinder dual mag engines. A conventional 6-cylinder engine, the accessory case spins 1.5 to 1 relative to the crank rotation. Well, you account for that by setting up a gear train system like what we have in our mag timing housing. In the 6-cylinder engines with the dual mag, that gear train spins 3/4 to 1. There is no conventional magneto out there that I'm aware of, other than the Bendix dual mag, that spins 3/4 to 1. So the engineering solution then was we either develop our own magneto, which I got to be honest, we looked at. That turned into a bit of a rabbit trail. Or the simpler way to approach it was put 2 electronic ignition systems on there and go the easier path, which was having a backup power system, which is what we elected to do. So for the dual mag engines or the DMAG engines, you end up with 2 electronic ignition systems completely separate from each other. So now you've got them isolated. They'll never have that 182 RG, as I mentioned, where because a nut didn't get put down well enough, and there's actually a service instruction from Bendix to address that the DMAG itself decoupled from the engine, the airplane had a forced landing and there was loss of life. Now with the 2 separate with the 2 ignition systems completely separated, the pilot has the opportunity to begin to isolate one ignition from the other if there's a problem, and then safely fly the airplane. I'm going to stop sharing. Bill, you had made a comment that you wanted to share a couple of things. Feel free to chime in if you want to unmute yourself.
Yeah, I was one of the original skeptics about 4 or 5 years ago, and Daryl kept making promises to me and so forth and so on. And so basically in the last 4 years, I've been involved in 4 installs, 2 on my own airplanes and 2 in planes in my hangar row, so to speak. 3 Bonanzas and 1 Cardinal, which has a dual system. But and just little tiny details in all of my situations, the electronic ignition went to the bottom plugs, not to the top plugs. And interestingly enough, every time we pull those plugs at annual inspection, there's nothing to clean. They're already clean. They don't accumulate any crap on them. And that's sort of a nice thing, because you get to the point where you're tempted not even to pull them out because you've never found anything to clean on them. Second point, if you compare the conventional mag drop between one and the other, I consistently see 10 RPM drop when I turn off the mag, because the electronic is carrying literally the whole load. If I drop the EIS off, the mag drop will be a full 100 RPMs, which is sort of conventional what we're used to. There was comment made about driving the tachometer in electronic systems. You mentioned JPI and you mentioned Garmin. I happen to have Dynon, and I don't remember all the details, but there is no flickering, no drop. It just goes from one RPM to the other RPM, and it's totally transparent. I was a little bit surprised to hear you say that cylinder head temperatures may be a little bit higher with ERS. Mine are actually a little bit lower. In cruise at 75% power, my CHTs are right at 290, 295. I rarely ever see one over 300. But the real proof of the pudding is the bloody engine runs so smooth, it's almost scary. You can lean it past peak, into lean of peak, and it never gets rough. It quits before it gets rough, which is sort of interesting. My first install was on a Debonair that had a lot of hot start problems, and it cured that without a doubt. My A36, which I've had installed for 2 years, never really had a hot start problem, but the running of that engine is phenomenal. That's all I have to say. I'm sold.
Thank you, Phil. I appreciate that. I noticed you changed the backdrop of your picture from your day job airplane to your personal airplane. So
Well, that was day job. They retired me. They said I was too old to fly jets, so now I have to dork around with Bonanza all the time. But yep, that was it.
They have to do something about this age limit. It's absolutely ridiculous.
Yep, I think so too, but they didn't listen to me. So
Wow.
well, I'm not getting any additional questions. Daryl, did you want to, we're getting, I generally like to wrap these things up at 9 o'clock. Because that way I can go sit and spend a little bit of time with my wife. Daryl, you had a special you were going to offer the group. I think this is a good time as any.
Yeah, for you guys that came on board tonight, we really appreciate it. I do have a special price to offer you for a single system, whether it be 2 of them for a Baron or a single system for a Bonanza. What we consider a complete package would be the EIS 61000-1M mag timing housing kit, 6 of our high energy plugs. In this case, I'm talking about the massive electrode plugs. And then of course, to really top off the installation, the EA 13000 ignition switch panel. The normal retail price on that package would be $52.28. I'm going to run a special for you guys. My installation centers are going to hate me because this is basically their discount. That complete package for $44.45. And I'm going to run that through. I'm looking at my calendar. Today is the 5th. Next Friday the 13th, will be the drop-off day for that pricing. That, just so you know, is actually below what we'll be offering at Oshkosh this year. Dual systems, if somebody wants to go dual, we can talk about that one-on-one. My phone number was up earlier. I'll give it to you again. 281-728-8732. Or you're welcome to reach out to me via email. My first name, Darrell, DARRELL, at smoothpowerllc.com. Last thing that I will mention that I stated earlier, I did spend 35 years in aircraft propellers. If you have questions about propellers, you need advice about propellers, especially you guys running the E185 and E225 Hartzell systems, I'm somewhat of an expert on that system. Give me a call. I'm happy to help you guys out. If you're looking to upgrade your prop, we're happy to give you our best price that we can. Other than that, that's about all I've got for now. Anybody else have any other questions? Don't be afraid to ask. Now is the time to ask questions.
Well, I'm not getting any more on the chat group, which is great. Again, I don't think I mentioned it. I might have. This has been recorded and it'll be up on YouTube in a few days once we get it trimmed and edited and that sort of thing. So if somebody wants to go back and look at it or look at the chat questions, those will all be available. Our email is sales@electroair.net. You can call us, email us. Sales questions will direct you down to Daryl. Don't forget as well, South Seas Ventures, www.southseasventures.com. for beach replacement parts. And whatever we can do to help, we'll be happy to do it. Other than that, I want to thank everybody for taking the time. Really enjoyed it. This kind of stuff's a lot of fun. It's nice to talk to a bunch of owners. So
One last thing I will quickly say, if you guys in your community find that you're running into a problem with a part, give Mike a call. He'll take a look at it. He is very good at getting these parts PMA'd, and it's all about helping the flying community keep these airplanes flying. It's really a cool business and something that I'm trying to get him to expound on. We've only got so many hours in a day. I operate Cessnas and Pipers, and we run into parts problems all the time, and trying to get him to do some of our parts as well. So if it's something that's common that you're seeing, get in touch with him. He'll take a look at it. Very, very possibly could be something that could be PMA'd and made a lot more reasonably priced to keep you guys flying. Phil, want to thank you very much. Appreciate you. Hope you come by and see us at Oshkosh. We'll be there. Barring any unforeseen craziness, we'll be there with our best smiles on. Of course, by Wednesday, we're not smiling. We're freaking tired. We're getting old.
It's a long week for sure.
Whoa.
Well,
Yeah.
everybody, again, thank you very much. Really appreciate you taking the time out on a Thursday evening. Look forward to working with you all.